two, three. You're live.
Thank you. Will someone introduce me or should I introduce myself?
Okay, so good afternoon, good morning, good evening, depending on where you are joining from. My name is Rashid Oguniran, and so we shall be having another session today. And the topic of discourse is going to be optimize Azure data solution. And our speaker for today's session is named Deepthi Goguri. She will be taking us. She's an SQL database administrator, a Microsoft certified trainer. She usually have MCSE. So we are on essential of data engineering, and so she'll be taking us through optimize Azure data solution. Ladies and gentlemen, let us all welcome to the podium our speaker for today, Deepthi Goguri. You have the floor, ma.
Thank you so much, Shahid. Hello, everyone. Thank you so much for taking your time for attending this session today for the data platform. Myself, I'm Deepthi Goguri. Today, we are going to discuss about optimized data solutions. So, basically, before beginning, I would like to tell you that this session is going to be about like what are the features that are available in Azure to take the leverage of improving the performance in Azure. So we are going to cover that. Just a little bit about myself. I'm a database administrator having 8 years of experience. I'm a Microsoft certified trainer and Microsoft certified solution expert. I did my master's in computer technology at Eastern Illinois University, and also I'm a co-organizer for a couple of user groups. I'm a co-organizer for a data platform and data data and AI South Florida user group. It's in Florida, and also I'm a co-organizer for diversity, equity, and inclusion user group, and a volunteer for women in technology. And I usually blog about SQL Server at dbanuggets.com. And if you'd like to contact me, Twitter or LinkedIn is the right way. LinkedIn, search by my name. Twitter, DBA Nuggets is my user ID. I would like to thank all of our sponsors for today presentations and for today's conference. Without your support, this event would not have been possible. Thank you so much. So when you listen about the performance, right? Whenever you listen about the performance, once you build your SQL servers, once you have the databases on-prem or in Azure, the main thing that differs is the performance. So no matter if we are on-prem or in Azure, we need to make sure our databases are secure and the performance that we are looking for is achievable. So, when do you call it as a performance in a general way, right? This is an open-ended question. Like everybody like says like when the queries are running faster, when my application is running faster, that's when we call it as a performance, right? And when do you call it as a the opposite side, right? When do you call it as a slow performance? That's when the chaos happens, and that's when we receive complaints of like, hey, my queries are running pretty slow, our application is we have outage, right? When we run certain queries, when we touch something on the application, it's totally rendering, but it is not actually getting the data. Now what's going on? And you receive that constant like non-stop calls to the service desk. That's when you know something is not right, and it is directly impacting the performance and it is directly affecting the business, right? So no matter where you are on prem or on cloud, you need to make sure your queries run pretty faster, and it's not all the time depending upon the resources that you are using in Azure, but also what features are you using. Are you taking the leverage of all the features, like all the uh, performance insight features, or like for example the query store feature that is available in Azure, the automated features that are available in Azure, are you really using them? And like when we talk about performance, what are certain important factors that we need to talk about? especially when we are talking about the performance capabilities. So when you plan to build a database on-prem or in Azure, what kind of things are you first looking for to build a server and a database? To build a database or server, you need to know how like what kind of system it is it an oltp system, is it an olap, is it for the report analysis, what kind of use do you what kind of thing uh, that you use for your database, and what application is pointing to the database, is it like a 24 by 7 application? And because based upon that you need to decide the capabilities, right, the maximum capacities that you want to use. When you talk about the maximum capacities, the important things that comes in mind are the CPU, memory, storage, IO, right? We need to make sure those are fall in place, those are available. Like if you're on-prem, you need to buy this kind of hardware ahead of time. But if you are in Azure, you can easily scale up and scale down because you do not own them. You just scale up and scale down, pay as you go, and that is one of the performance capabilities as well, right, because it directly impact the performance. The next thing is related to the data, the indexes. So your tables have those indexes. How are you taking care of those indexes, and what is the difference between on-prem and in Azure? The main difference is like you can use all type of indexes. You can use the column store indexes, online offline indexes. You can resume the indexes just like the way you do it on prem. You can do it in Azure, but the advantage that you have if you are in Azure is you can automate certain things like maintaining the indexes, and there are certain things known as like index recommendations that are available in Azure, where it will give you the list of the indexes that are not being used based upon the analyzation of your data. It will analyze your data for certain period of time, and it will give you the report, the unused indexes report. And if you create certain indexes, it will provide the performance. In that case, it will suggest you the indexes. And the other advantage is you can automate this process. You can view the indexes and you can go ahead and automate this process to create it by itself. So when you automate this process, it will go ahead and analyze, it will provide you the report, and if you agree, it will make the changes. So you have the options to choose what to do through automation, and this is in Azure. And when we talk about in-memory OLTP systems, you can take the advantage, but as in Azure, the Microsoft is going to take care of adding those file groups for your OLTP systems, right? They are taking the responsibility to add these. In memory OLTP systems are especially available in the business critical databases in Azure. And there is one more thing known as intelligent performance. It's a very beautiful feature in Azure that we are going to talk about it, and I'm going to show you certain things in Azure, how it is available and how to take the advantage of this feature as well. So when we talk about the capabilities, right, there are like different tiers, and like if you see the service tiers, like general purpose, business critical, and hyperscale, and there are like different compute capabilities and storage capabilities that are available. I'm not going to walk you through with this slide, but if you see like for the purpose, like depending upon the purpose, you can choose the compute and the storage resources, and what are the maximum capacities that are available here. Everything is placed in this slide so that it will be beneficial for you. You can go through it later. So what kind of factors that are really important when we are building a database in Azure, and when we want to make sure the performance that we have through the database is good, right? So the first thing, like there are certain factors. One of the factors is the temp TP factor. Though the temp TP is stored in the local SSDs for the better performance in Azure. And for the Azure for the Azure SQL especially, we have 16 files in max that are available. For the managed instance, we have maximum of 12 files that we can use. And the location is always a local SSDs because they want more performance. That is automatically happening in Azure. And the size and the number and the location is like you can choose the files, but you cannot choose like where the location is because that is that is taken care by the Microsoft because it is in Azure. And when we talk about the database configuration, the first thing that we need to know is like databases are always in full recovery mode because of the SLAs, the service level agreements. You cannot place that in a different mode like a single user mode or like bulk logged recovery model, those kind of recovery models. Databases are always in full recovery mode. And you can use the max dop feature, and especially you can also use this max dop feature when you are using the query store hints. And you can also take the advantage of alter database scoped configuration as well when you are in Azure. The files and file groups, you can add and change the file sizes as well. But the user defined file groups are available in managed instances specifically. So, how do you maintain the performance in Azure, right? So the performance is directly like the performance is always impacted by how you are handling the indexes within your tables because the query engine, no matter if it is in Azure or if it is an on-prem, the query engine will use the certain paths to get your data, right? And indexes are the main part of the performance. And if you maintain your indexes, like if you have the specific indexes that your query engine uses, that will that will give you the performance. And if you do not have the indexes that you need to have, that will also impact the performance in a wrong way. And indexes as well as the statistics on those indexes are important because if you have stale statistics, that will impact performance as well because your engine will actually know how to get the data through the indexes by using the statistics. It will go and search the statistics and see the trend in the data, and then based upon those statistics information, it will provide the resources to get the data like the CPU, memory, that kind of information is actually allocated based upon these statistics. So if you are in Azure, right, how do you maintain these indexes and statistics? You can use Azure automation to maintain these indexes and statistics to update them. And one of the way is to create the Elastic Agent jobs. So how do you create these Elastic Agent jobs? Let's go ahead and see these automated job, how to create this automated job. So before that, we need certain things to create and automate these jobs. You either need to have any kind of performance scripts that you want to use to update your statistics and indexes, or you can use the free tools, free scripts that are out there for free, like Ola Hellengren scripts to maintain your statistics and indexes. And to create this to create this automated job to maintain your indexes, you need an automation account in hand, and then you need to use the SQL Server module. So SQL Server module you need to download from the Azure Marketplace, and then you need to create a credential, and upon that you need to create a runbook and place that runbook as an automated task. So let's go ahead and see how to create that. Let's say we have actually downloaded the Ola Hellengren scripts, and as you create the Ola Hellengren scripts by following the procedures, which are available online for free, it will create some of the store procedures to use to actually automate these maintenance tasks. So these are a couple of the store procedures that are actually gets created within your database. So here first the thing is to create an automated account. So I have provided the screenshot because we do not have much time to go through the demo in detail, but this will give you an idea of how we can actually create. Very simple, with couple of clicks you can actually create. You need to provide the subscription detail, a resource group, and the region, right? And then you can give the network connectivity. How do you want to give the network connectivity? And the basic information to create the automation account. So once you click on create, it will create an automation account. And once the automation account is created, you need to create a module. The SQL Server module, you need to download this particular module from the marketplace. And then once the module is completed, you need to create the credentials that will actually run this particular automated job. So I have added a credential with my name, right? So once you create the credentials, the next thing that you need to do is create a runbook. So while creating the runbook, you need to create you want to use the variables within that runbook. So I have created the database name as a variable, as well as the SQL Server database as the logical server name as a variable. So under the variables, you can see the variables, you can create the variable, and then I'm going to create my runbook to actually run that particular Ola Helen Grin script as an automated task. So here in the runbook, you are providing the name of the credential, right? And then providing the variables on which SQL server, like which automated variable on which SQL server, and then the database information as a variable. And if you see the details, you are actually running that Ola Helen Grin maintenance script here. The last line show you like execute Azure SQL maintenance and what is a query timeout and the other information. Once you create the runbook, now you need to go ahead and schedule that, right? So you can schedule that within the Azure Data Studio, within the Azure portal. You can, while creating the runbook, you can also schedule that. So here I'm creating a schedule, but creating a schedule doesn't mean that you cannot run it manually, right? You can also run it manually. So for this particular demo, I would like to show you how to actually manually run it along with the schedule, just to test it out how it is working. So my indexes, I have executed a query to get the index fragmentation information. So the first screenshot shows you like what are my what is my database ID, object name, and what are all the indexes we have, and what is the fragmentation level. So if you see, two of the indexes are already fragmented, like nearly 100%. So, and also I wanted to check like when is my indexes lastly updated, and they were never updated, and that is the reason like it's too much fragmentation happened. Now I would like to take the advantage of this automated job that I'm running, like the maintenance task that I'm running through Olahel and Grin scripts using the automation job through Azure. So as we created the run book, right, as we scheduled it, we can also actually go ahead and manually run it. Go to the job, right? Go to the job to that run book and then click on start, which will run the job, and then go ahead and check your check your index fragmentation one more time to see how it works. So if you see the fragmentation level after the job executed, it has there is no fragmentation, and my lastly updated details of my indexes are available as well. If you see here the last updated date, right, on the statistics. Now the other advantage, like the other beautiful advantage of being in Azure is to take the advantage of query store. So basically the query store is introduced, this feature is introduced in SQL Server 2016 and above, but the like it is already available in on-prem servers. But the advantage of having of being in Azure is like you can use like automated plan correction, which is a part of the query store feature. in Azure. So what do I mean by that? Before knowing like what is the automatic plan correction, let's talk a little bit about what is query store. So basically, query store will actually, like, it is a database level feature. You need to actually enable it manually when you are on-prem on the database. But if you are in Azure, the query store is already enabled on the database in Azure. So what it will do is it will collect all your queries along with the execution information and also the resources that it took to execute the query along with your execution plan information. So it will collect all this information over time. So let's say your query have like multiple execution plans. It will save all of those execution plan information over time within the within the database itself. Um, so so when you enable the query store on-prem or in Azure, it is automatically enabled, right? So that particular data that is being collected is also stored in the database itself in the primary data file of the database. So you can use the system views, especially designed for the query store, to grab that information, or you can use the graphical user interface to see the information from the SQL Server Management Studio by connecting to the Azure SQL database, or you can see the information from the Azure portal as well. So let's go ahead and see couple of a couple of demos of like taking the advantage of automatic plan correction. So not only like analyzing the data by looking at the data that is being collected through query store by using the management studio, that is another advantage. But the next level advantage of having query store in Azure is like you can take the advantage of automatic plan correction. So what this automatic plan correction does is it will automatically collect the information regularly, like the query store, but you do not have to um, go ahead and analyze and then um, analyze the execution plans and then force any plans. So, the advantage that you have by having the query store is to not collect the data, but also to analyze your execution plans and to force a plan that you think is optimal. You can compare two execution plans or three execution plans side by side for your query, and if at all the other plans are getting activated and uh, they are running and that is causing the issue with the performance, instead you can check for the different execution plans, and if you think one plan is working better but it is not taking the advantage, you can actually force that plan that you think is optimal. Manually, you can do that when you have the query store, and you can do that when you are in on-prem or in Azure. But if you are in Azure, the automatic plan correction will take that to the next level of it will go ahead and automatically analyze it for you. You do not have to manually force any plans. It will go ahead and manually analyze your execution plans, see the difference between them, and if the previous plan is not working better, but if the new plan that got generated is working better, it analyzes the information internally and it will automatically force the new optimal plan for you so that you don't have to manually go ahead and um, force a plan, because it is tedious to go ahead and observe all the execution plans and like analyze force them and make sure like the force plan is all the way optimal later down the road. It is very tough because if some other plan got generated for some reason, um, and then you need to make sure like hey, new plan is better or is because some other plan is being forced now. So you need to make sure like constantly make sure like hey, what are the plans getting generated. But having this automatic plan correction, you do not have to worry about that. It will go ahead and automatically force the best plan for you, right? It is a constant plan regression comparison, and it will go ahead and constantly look for the plans that can be forced or that can be unforced and then force a new optimal plan. Now let's go ahead and see a demo of how this actually works. I'll share my management studio. So what we are doing here is we are connecting to the Azure Data Studio. Sorry, we are connecting to the Azure SQL database by using the SQL Server Management Studio. We are using AdventureWorks database, and here we are looking for like how automatic plan correction works. So let me go ahead and connect to the database. Um, this is Azure, right? Let me connect to the Azure. This is connecting to local server. Let me connect to Azure SQL database. And then now let me go ahead and alter the database name, set automatic tuning, right? To take the advantage of it, set automatic tuning, force last good blank to be turned on to turn this feature on. Set automatic plan correction to be turned on. But by default, it is turned on. You can turn it off. But then I'm just making sure to let you know like how we can actually enable this automatic plan tuning. This is the query we use. So if I execute this one, right, I put the database in the auto pause mode. Um, like if there is no activity for 1 hour for my database, it will go to the paused mode. So it is taking some time to get connected. That is the reason it is taking some time. It is trying to connect to the database, but the first connection will fail because it's in the paused mode. It's been more than an hour that I connected to this database. I'm sorry, it is taking some time. So it is currently connected. So now let me go ahead and alter the database, set it automatic tuning to be turned on. Now I would like to go ahead and see if it is actually turned on by selecting this view, select star from sys database automatic tuning options. If I execute and see the results, the force last good plan is turned on, right? And is also, do you remember I said like there is also other automatic tuning options available, the create index and drop index. You can actually turn it off if you want, right? It will provide you the recommendations of a report to create the index and the drop index, and also the maintenance of indexes. So for now, we are looking for the last good plan. So it is turned on. So what I'm doing is I'm just going ahead and creating this particular store procedure, right? It is a simple store procedure, selecting couple of columns from this table and where product ID, and I'm creating a variable like a variable, executing the store procedure. Now I would like to clear my store procedure, clear my query store just in case, and then see how the query store looks like. If you see here, I'm expanding the database. Once you enable the query store on-prem, you'll see this query store folder. But if you are in Azure, it is automatically there because query store is automatically enabled. So expand that and go to the top resource consuming queries, view top resource consuming queries. Now we did not executed any query, so it did not captured anything. But now I would like to go ahead and clear my procedure cache just in case. So we are starting from the scratch. Now, as we created that store procedure, I am going ahead and running this particular store procedure for 50 times. Now, why I am running 50 times is because I would like to create the workload, because once you run the store procedure one time, it won't force any automatic plan correction. There are internal algorithms that it have to check. There should be some kind of a workload happening, like certain amount of workload, certain threshold it have to hit to make sure this automatic plan correction is actually working. So because it will analyze the data, right? It won't analyze just for one execution. So that is the reason we are running for the 50 times. I'm executing that. And if you go ahead and refresh your query store, here I'll go ahead and click on um, view top resource consuming queries in a grid format to see the query. So the query ID is the 18. right? And this is the query that we have executed. It's in the parameterized view format, but then we got the plan ID. So what plan has been used for that execution is actually captured, and all the other information, like all the other metrics, are available here. If you see, you can change, go to CPU time, and then grab the information of CPU time, hover your mouse over here and see the CPU time it took, right? And then I'll see the duration in milliseconds, just in case, and then see how many milliseconds it took. It took average amount of 14 milliseconds. Now I have executed that workload. Now I will go ahead and clear out my cache, and then I want to create the regression. Now, if you see the execution, this particular execution, right? It took very less amount of time, 14 milliseconds. But this particular other parameter 707, it produces more records than this one. So let me execute and show you the results. If you see the results, the previous execution will provide only like around like 300 rows, but this one, if you see, each execution is providing like 237 k rows, too many rows. So that is the reason I actually only executed for 10 times this regression. Now, if you go to the query store and then refresh, right? Refresh button here. So as I refreshed, if you see, the plan ID 2 is the actual this plan ID for this particular second execution. But if you see here, there is a little tick mark over here. That means this particular query plan is automatically being forced. I did not force anything, because if I need to force, I need to if I need to manually force, I need to click on this one, and then I need to click on this force plan to force this plan. But as we are using the automatic plan correction, it analyzed the results, right? It went ahead and analyzed the results, like how much time it took for this particular regression, this particular query. It executed only 10 times, but each execution took like 1600 milliseconds. So when compared between these both, it thought that this execution is good and it forced this plan automatically. So that's how the automatic plan correction works. It will automatically analyze your queries, and and it will also show you the recommendations, like select star from sysdmdb tuning recommendations, to show you like why it has actually chosen the plan one to be forced, right? So so this plan ID one is being currently forced, and if you run this particular view, system view, execute that one and see the results. The force last good plan reason is like average CPU time. So there is this internal average CPU time it have to hit to change the plan. So until that average CPU time is hit, the automatic plan correction will not take the action. So the average CPU time has changed from 1.76 millisecond to 625 milliseconds, and that is the reason why it actually went ahead and forced the plan. And if you see here, it will also provide you the details. If you copy the results here, and then if you paste it over here, it will actually provide you the code if you want to manually force it. It actually forced it automatically, but also it will provide you the query if you wanted to manually see what query and how it actually executed. You can also manually see this one. It will provide you in that particular table, in the recommendation table. That is how the automatic plan correction works. And then query store hints. Query store hints is something like it is available in the preview mode currently in Azure. So what it does is, like, if you have the parameter sensitive queries, right? Parameter sensitive queries, most of your queries are using one execution plan, but these are little one or two parameters that are that are totally different, that are causing parameter sniffing problem. And for some reason, if you run those queries at the first time, and if they do scan on the table, the next time you run the same store procedure with any parameter, it will go ahead and use the scan because the plan is being saved in the plan cache. It will go ahead and take that plan. But to avoid that kind of parameter sensitive problems, what do you do regularly? Like in the general way, you will go ahead and either like um, use like you'll go ahead and recompile the store procedure, right? And you'll be changing the code of the text of that store procedure to do the recompile. But what if you do not even have to touch any underlying code, but make that thing possible to fix that parameter sensitive query? That is when the query store hints come. Like when your query store is turned on for your Azure SQL database, you can use this particular query hints to solve the parameter sensitive queries, to solve that parameter sniffing problem. Now, to show an example for that, I have created the same store procedure. This is actually connecting to my local system. Let me change that to Azure SQL database. And if you see here, right, this is the same store procedure that we have actually executed in the previous demo. But let me create that one by dropping it again. Um, I need to execute that in Adventure Works. So it is done. It is created. Now I would like to clear my query store and the procedure cache before beginning. Now this 870 parameter, right? We will see how many rows are resulting, and let's do this by enabling the actual execution plan on and execute it to see like how many rows are we getting, right? Now here, if you see the results, how many results? 360k rows. And if you see the execution plan, it has actually did the clustered index scan because look at the results, 360k rows. Now let's go ahead and see how many rows the second execution. Like after creating the store procedure, we have firstly executed this one. So it got too many results, and so it did a clustered index scan. But this 942 parameter, let's see how many results we get. This is just 385 rows. And if you see the execution plan, it still uses clustered index scan. Now, does that make sense? Because we do not have to do this, right? For the 385 rows. But then as we created the store procedure, the first time we executed, this plan that produced the 380k rows, it created the clustered index scan execution plan, and that's been saved in the plan cache. So the next time we run any parameter, it took the same plan, which is not needed for 385 rows because it is taking a lot of resources. Now, how do you fix that? Right? By recompiling, but we do not want to change the code. So by using the query store hints, what we can do is by using certain views, you can go ahead and actually grab the query ID for this particular um, query that we executed. So I used the product ID um, as a text of that particular store procedure to grab the query ID. In the results, the query ID says as 1. So once I found out that query ID, there are certain store procedures, especially designed for this query store set hints. All you have to do is like set sp query query store set hints. We are using for the query ID 1. Now what option you want to use? The query store hint option, what you want to use. I want to just recompile this particular query whenever it runs. So instead of changing the code, I can use this particular store procedure, provide the query ID, and then use the option as a recompile. Now let me go ahead and execute that. I did not change any code for the store procedure, right? Now I will go ahead and run these two particular, the same store procedure executions, right, with the same parameters. And now let's see how it will actually execute. Now, if you see here, the first one produced like 360K rows. It went ahead and did the clustered index scan. But the second one, this time, as we are using the recompile query store hint, it went ahead and recompiled and it created index seek, right? Index seek, it sniffed the parameter and it took the right decision. And how do I know what kind of hints are enabled for my store procedures or for my queries? By using this particular query, um, by using this particular view, you can see all the enabled query store settings that are currently enabled on your database. So for this query hint ID 1, for the query ID 1, we are actually using option recompile that is currently enabled. Now, what if I would like to go ahead and change that? Instead of using like instead of using recompile, I would like to change the max stop. There are several options you can use, not only the recompile. You can use the max stop one, you can use the compatibility level, you can mix and match the query hints for this particular query store settings. So right now I want to use the max stop one. So let me go ahead and execute that and then clear out my cache, right? And then execute this execute this particular um, queries again, like the store procedures. And now if you see, we removed the recompile, so it did not apply the recompile. But then if you see the properties in the select and see the max stop non-parallel plan reason, max stop set to 1 for both of them. For both of them, it applied the max stop set to 1, right? But what if I would like to go ahead and use both of them, recompile and max stop, both of them? You can go ahead and update for that particular query ID. Once you execute that, and then clear out my cache, and then execute the same store procedures again to see how it will actually act. Now, if you see, we have used both of them. One is recompile, so it recompiled, and the other one is set max stop to 1. So if you go ahead and see the properties, it applied both of them. Max stop set to 1 for both of them. For both of them, it applied. So you can mix and match. And then if you see like what are the current options here, for my query ID 1, we have changed 3 times, right? But will that show in our results? It doesn't show. All it says is like query hint 3, query hint ID 3 is used because it changed 3 times. And that is the third one. This is the third one that is currently active. And what is the third hint? The updated hint is using 2 query hints at a time. But it will not provide you the history of the information. But how do you get that history of the query hints information? You can use the extended events to capture that information. And you can see this all the supported and unsupported query store hints from this link. And if you'd like to know how to actually create the extended event session to capture all of that information, I have written a blog post in dbanuggets.com under the query store tab. You can find the query store blog post. You can see one of the blog posts tell you like how you can actually use a extended event to capture that information. So that's my demo. Let me go back to my slides back again. And also, once we completed the query store right now, let's see the automatic tuning options we have. Like once you open up the Azure SQL database, left side your pane, you see automatic tuning. Like I said, we have the automatic tuning for the force plan, uses the query store. We just discussed that one, and you have create index and drop index recommendations as well. Like it will go ahead and analyze the data, give you the report. You can go ahead and analyze and see how much impact that index can make if it is recommending you to create that index, and then go ahead and automate it. Now let's go ahead and see how that actually works. Now I have a recommendation, right? My automatic tuning is currently on. So what it shows is like in the in the notifications, underneath the overview of your Azure SQL database, it will say three notifications currently available. And underneath the performance overview, if you go ahead and see the performance overview, it will says, hey, there is a recommendation for you. And that is like create index recommendation. Let me go ahead and see what is that recommendation. And if you see, it is recommending the create index and on which table and on which columns and what is the impact. There is a high impact. So you can go ahead and see the details on clicking that, like what are the details and what are the columns it is recommending. And you can actually apply that. You can on the top of it, you can hit apply to apply it to create the index. There is also a query performance insight where you can go ahead and click on the
So,
Azure SQL
hello,
database.
Deepthi.
Yeah,
Hello, can you hear me?
yes, I can hear you.
You have 5 more minutes.
Sure, I will be completing that. Thank you. So we
Okay.
also have the under the Azure SQL database. Go ahead and click on Query Performance Insight. This is one of the another feature to actually take the advantage of when you are in Azure. So basically, it will show you all the top resource consuming queries. And if you see here, the red color bar graphs, right? Those are like top resource consuming queries, and underneath that you can see the query id and what are the resources that are using. And if you want to see the query id and expand that by clicking on it, you can go ahead and see what is a query and what are the metrics that it is actually being used, like what is the cpu, io duration, and what is the execution count information. And these are like the advantages, like the main advantages that we have seen is the query store, performance insights information, automatic tuning. Please take the advantages of these features to improve the performance in Azure. I would like to thank you one more time for attending my session. And yeah, it will be an honor to get in touch with you again. DBA Nuggets is my user ID for the Twitter. If you have any questions regarding this session, please let me know. Thank you.
Okay. Thank you so much. Thank you so much, Deepthi. This is a very loaded section. It's not something. It's not a session that somebody can just consume once and just be up and running. But then with continuous reading, continuous research. But may I ask, is there anything, any resources you can just
Oh,
give to
yes.
our viewers? Maybe they need to make more research so that they can build on this foundation that you have just laid for them to help their learning.
Sure. So you want me to provide the resources of this slide of this session slides, or do you want the demos, or are you talking about like any Microsoft Docs to learn more about
Yeah,
that?
yeah. Link that exactly people that are watching that they can, build on, because I'm sure this session will be available on YouTube. So as they watch the
Yeah,
session, is there any write up or link that they
yeah.
can just theory so that they can use to build on the foundation? So that's what I'm asking for.
Oh, yes. I mean, there are other like if you see the
And,
query
and,
store,
and if you can release your material too, we don't mind. We
yeah.
will ensure that it's well taken care of.
So it's in my GitHub repo. Let me share my GitHub repo because you have all the links to that fundamentals of query store. You can see this one, and I will
Okay.
also upload this presentation later. But I have placed it in the chat window.
Okay, that's fine.
Yeah, and in that particular presentation, in the last slide, you have all the resources to know more about the query store and other features.
Okay, okay, okay. Thank you.
I
So
will
we
also
have a
I
okay,
will
go
also
on, go on.
upload I will also upload my slide deck to the same location if you would like to go and look into.
Okay, that's fine. So we have our feedback form for our viewers. Please, we will appreciate if you guys can help us fill those feedback form. What is your opinion about this session? What is your take home? Is there anything we are not getting right that we need to make amend? Because things of this nature, there is something they call continuous process improvement. So if there is any area that you observe that we need to improve upon, so do let us know. And the only way we can know all this is when you fill our feedback form. Please, we'll be very glad if
Yes,
you can
please.
fill our feedback form so that it will help us to know how we can move. So, thank you so much. If there is any question, please do let us. Okay, thank you. I appreciate. I saw the link now. Thank
Yeah.
you. So I'll
Rashid,
copy
I
it
have a
as
question. How do we know
okay.
like how many people attended our session? Can I get a count of it?
Okay, so we have our people at the back end.
Mm-hmm.
They will be the only person to determine because as we are running this section, we are equally on live on YouTube.
Mm-hmm.
So they will be the one to determine the number of people that are viewing. So if you need those facts, I can always reach out to them and so that they can let you know.
Sure,
Is that
thank you
okay?
so much. Really appreciate it. I need
Okay,
that.
that's
I
fine.
need that count. Yeah. Thank you.
Okay, okay. I will reach out to our project manager. I'm sure our project manager is equally on this call, and if she's not, after this session, I'll reach out to her to let her know, to let her to so that I can keep her apprised of the development. Thank you so much.
Really
Is there any
appreciate it.
question? Any question? Any
And
question from the audience?
yeah.
Okay, if
Uh,
there is no question,
I would like
so
to just provide my
so I
social
want to
media.
thank you. I want to thank all our viewers. If you are watching this session, I want to say thank you for coming, and we do not take it for granted. And also, we thank you specially, Deepthi Guguri. Your session is so loaded. Um, I will still because for me, it's a big deal for me. All those things you are doing is as good as we are doing in magic. But I know by the time I go through those learning parts and study and studying again, I will get better. Thank you so much, and we
Thank you so
appreciate your
much.
time. Thank you,
Thank
and
you.
God bless.
Bye bye.
So,
Thank you.
bye bye, bye bye,
Bye
everyone.
bye.
Bye bye. See you same time next week. Bye.